Physics, part 195. Next we talk about the frequency per hertz. For sodium it's 5.8 into 10 raised to 13. For calcium it is 7.0 into 10 raised to 13. For zinc it's 8.8 into 10 raised to 14. For silver it's 1.0 into 10 raised to 15. For platinum it is 1.4 into 10 raised to 15. And there are positives: 2.4 for sodium, 2.9 for calcium, 3.6 for zinc, 4.3 for silver, and 5.6 for platinum. Remember, 1 eV is equal to 1.6 into 10 raised to minus 19 joules. If the frequency of the incident radiation is equal to the threshold frequency, the energy carried by each photon is just sufficient for electrons at the surface to escape. If the frequency of the incident radiation is greater than the threshold frequency, surface electrons will escape and have surplus energy in the form of kinetic energy. These electrons will have the maximum kinetic energy. If a photon interacts with an electron below the surface, some energy is used to take the electron to the surface, so that it is emitted with less than the maximum kinetic energy. This gives rise to the range of values of kinetic energy. Einstein used the principle of conservation of energy to derive photoelectric equation. Photon energy is equal to work function energy plus maximum kinetic energy of photoelectron, or HF is equal to theta plus 1 MeV max square. For radiation incident at the threshold frequency, half MCV max square is equal to 0, so that HF0 is equal to theta. The photoelectronic equation can be written as HF is equal to HF0 plus 1 over 2 MeV max square. We've got an example for you. The work function energy of platinum is 9.0 into 10 raised to minus 19 joules. Calculate A, a threshold frequency for the emission of photoelectrons from the platinum metal. B, the maximum kinetic energy of photoelectron when radiation of frequency 2.0 into 10 raised to 15 Hz is incident on platinum surface. A, using HF0 is equal to theta and F0 is equal to H. F0 is 9.0 into 10 raised to minus 19 divided by 6.6 into 10 raised to minus 34, which is 1.4 into 10 raised to 15 Hz. Well, using the HF, we get an answer of 4.0 into 10 raised to minus 19 joules. Now it's your turn. The function energy of silver is 4.3 eV. Show the threshold frequency about 1.0 into 10 raised to 15 Hz. Number 2, electromagnetic radiation of frequency 3.0 into 10 raised to 15 Hz is incident on the surface of sodium metal. The emitted photoelectrons have a maximum kinetic energy of 1.6 into 10 raised to minus 18 joule. Calculate the threshold frequency for photoemission from sodium. We've got a section summary. Electrons may be emitted from metal surfaces if the metal is illuminated by electromagnetic radiation. The phenomenon is called photoelectric emission. Photoelectric emission cannot be explained by the wave theory of light. It is necessary to use the quantum theory, in which electromagnetic radiation is thought of as consisting of packets of energy called photons. The energy E of a photon is given by E is equal to HF, where H is the Planck constant and F is the frequency of radiation. The work function energy of a metal is minimum energy ceded to free an electron from the surface of the metal.